Hello all, this is Saranya, working as Assistant Professor in the Department of Computer Science and Engineering at Sri Muthukumaran Institute of Technology near Mangadu, Chennai. Today we are going to see the subject Algorithms. Subject code is Cs3401, which comes under Regulation 2021 under Anonymity. And the objective of this course are to understand and apply algorithms analysis techniques on searching and sorting algorithms, to create and analyze the efficiency of graph algorithm, and to understand different algorithms design techniques, and to solve problems using state space tree, and to understand the concept behind NP completeness problem, approximation and randomization algorithms. At the end of the semester, students could be able to gain knowledge in the course to analyze the efficiency of algorithm using various frameworks and apply graph algorithms to solve problems and analyzing the efficiencies, and make use of algorithm design techniques like divide and conquer, dynamic programming and greedy techniques. Use the state space tree methods for solving problems and to solve problems using approximation and randomization algorithms. Today we are going to see the topics introduction to algorithm, time complexity, space complexity, and approximation notations and its properties. Introduction to algorithms. Definition of algorithm, as we always see the definition, algorithm is nothing but step-by-step procedure to solve the problem. But we are having an official definition for algorithm. This is the official definition, that is formal definition. And algorithms is the sequence of unambiguous instructions. Unambiguous instructions is nothing but without any confusions, clear picture about the instruction of for solving a problem, for obtaining a required output, for any legitimate input in the finite amount of time. This is the formal definition. An algorithm is a sequence of unambiguous instructions for solving a problem, for obtaining a required output, for any legitimate inputs in a finite amount of time. This is notion of algorithm. Once we get an algorithm, once to solve a particular problem, first we have to analyze the problem, then we have to create an algorithm based upon the problem, and then only we have to feed the algorithm to the computer. Then we have to check whether the algorithm is properly running or not. We have to give the input, and so that we can get the output. The output can be a correct one or it may contain error. This is notion of algorithm. Next, the properties of algorithms. There are several properties of algorithm. These are some few properties. Non-ambiguity. First one is non-ambiguity. Non-ambiguity is nothing but without any confusion you are going to write the algorithm, but without any complexity we are going to form. It's range of input. The range of input must be finite one. And the multiplicity property. Multiplicity is nothing but we are going to write the algorithm in forms of natural language or the pseudocode or for any flowchart basis. Next one is speed. Algorithm can be run in efficient speed. And finiteness. Finiteness is nothing but it must contain a finite amount of steps. These are the properties of algorithm. Then we have to know how to write the algorithm. The algorithm can have written in some as in C programming language. Very few patterns are varied. An algorithm consists of heading and body. In the algorithm, you have to write heading along with the body. Heading includes keyword algorithm, name of the algorithm, and its parameters, if any. This is an example for algorithm heading. Algorithm is a keyword. Addition is the program or name, and A comma B the parameters of A comma. Next one is this heading of algorithm. The heading should include problem definition, input, and output. Problem definition is nothing but what is the problem? Addition of two numbers. This is the problem description. Input is A comma B. Output is A plus B. This is sum of two numbers. This is example. Next one is algorithm body. Algorithm body should include all the other characteristics included in the C program. Assignment statements, if statements, while statements, for, while, any kind of operations. Assignment operation in the C program we are using is equal to symbol, but in this form of algorithm we are using back arrow for assigning the values. For variable is equal to expression. In the C program, variable is equal to expression, but in here variable arrow expression. For loop, we have to describe like this. For I, in the C program, for I is equal to 0, I less than n, I plus plus simply the statement. But here, variable is equal to value to n, do the steps 1 to 1. Step 1, set statement 1, 2, 3, set up to n. Up to n, n plus 1, it will keep on continuing. Next, we are going to see the topic time complexity. Time complexity is nothing but amount of time required to run an algorithm. That is time complexity. By means of using normal physical clock, we can't measure the time because it depends upon the load of the computer. It may vary from system to system. So we cannot predict the time complexity based upon the physical clock the system. Normal physical clock. So we are going to measure the time complexity by means of using frequency count. So frequency count is nothing but number of times a particular statement is executed. How many times the particular statement is executed. So in the given example, sum of n numbers is in an array. See the statement sum is equal to 0. This is an particular statement. So this statement will take how long it will compute. For I is equal to 0, I less than n, I plus plus. How long these statements are going to run. Sum is equal to sum plus 5. How long this statement is going to run. So how many times these statements are going to run, we are going to see. For I is equal to 0. I is equal to 0 is nothing but it will run only one times. Then I less than n. See after 0, 0 to n times it will run. So I less than n we have to prove. So for n for here the execution time is n plus 1 times, n for true statements and 1 for false statement, for running false statements. If that is f I is less than n is runs for n times, and I is not equal to less than n is nothing runs for one time. So it will take n plus 1 times. So I plus plus is nothing but it will run for n times. Up to n times it will run. Keep on run. This is a looping statement. It will keep on run for up to n times it will run. So I is equal to 0 run for 1 times, I less than n for n plus 1 times, I run for n times. Then we are going to the inner loop. Sum is equal to sum plus a of I. So this is another. This one is to keep on running for up to n how to n times. So the statement will run for up to n times will run. This statement is going to run up to n times. So totally 1 plus n plus 1 plus n plus n times. So 3n plus 2. So totally it comes under 3n plus 2 times. So in this we are going to neglect 3 and 2 constant values. So only we are going to take the n value. So time complexity of T of n is equal to nothing but order of n. Next is time complexity. Another one example is matrix addition. So we are going to have two for loops. I for I is equal to 0, I less than n, I plus plus, and j is equal to 0, j less than n, j plus plus, and this is the instruction statement. So I is equal to 0, as we discussed in the previous example also, I is equal to 0 runs for 1 time, and I less than n is run for n times, n plus 1 times, and I run for n times. When you go inside the inner loop, this will run along with this outer loop. So j is equal to 0 run for 1 time, but along with I is equal to 0 run for n times, that is this is the inner loop. So n times it will come. So the n into 1 time. So n into 1 times this f j will be run. J less than is equal to already this includes n plus 1 times along with this n time n into n plus 1 time. And j plus s is also n times is run for j plus s loop, and for outer loop is also run for n times. So n into n times for j plus s. This one is also included. So inner loop, outer loop is for n times, inner loop for n times. So it will include n into n times. So n into n times into n square times. So when we summing up all the statements, so we are getting 3n square plus n 4n plus 2. So we are neglecting all other constant values. N square plus n is the remaining value. When compared to n square and n square takes the maximum time. So we are going to use this as the time complexity. That is time complexity of matrix addition is order of n square. Next one is space complexity. So space complexity is nothing but amount of memory space we are required for the algorithm. So it includes two factors, constant factor and instant characteristics. So constant factor is nothing but some constant values. See for int a comma b comma c means a comma b comma c is constant values. That is it will not change at any state. So this is a fixed part. So space and inputs and output values are under comes under constant values. Next one is SP. SP is nothing but instant characteristics. Instant characteristics is nothing but for the each for the sorry for in the loop and all we will keep on changing the values. Depends upon the value of some particular value. You can see in the example. You can so that you can get clarity. So this is a formula for space complexity. S of P is equal to C plus SP. So this example of one example of space complexity, addition of three numbers, add a comma b comma c. So in this as an algorithm, add a comma b comma c. Program problem distribution is nothing but addition of three numbers. Input is a comma b comma c. Output is addition value. So return a plus b plus c is a statement. So a includes one unit space for a, one unit space for b, and one unit space for c. There is no other any loop statements and all. So space complexity is equal to S of P is equal to C plus SP. So SP is not in the program. So C is equal to 3 plus 0 is equal to 3. So space complexity is 3. Next one is sum of n numbers in an array. So in a given array, n numbers are there. We are going to sum it up. So initial sum is equal to 0 for I is equal to 1 to n. Sum is equal to sum of sum plus a of y returns sum. So so these are the constants. I is constant, sum is the constant, n is a constant. So for these constant values, we are going to give one unit spaces. I 1 unit space, n unit 1 unit space, sum 1 unit space. So here a of I value which keep on changing depends upon the value of n. When it comes, if I is equal to 1, a of value is 1, I is equal to a of 2. Up to a of n, we are going, this value is going keep on changing. So this comes under some variable part, that is instant characteristics part. So 3 for C, so this is the formula SP, S of P is equal to C plus SP. So C means 1 plus 1 plus 1, 3 plus S of P is nothing but it runs for n times, so n. So this is the space complexity for addition of n numbers. Next topic is asymptotic notations and its properties. So asymptotic notations and its properties means we are going to find the runtime of an algorithm. We are going to find the runtime of the algorithm without using any algorithm techniques. So these are the notations, three main notations: Bigo notation, theta notation, omega notation. So this is a very important question. Bigo notation is nothing but it is represented as O, biggest O, and represented by upper bound algorithm running time, and it also takes longest amount of time compared to other algorithms. So definition is nothing but let f of n and g of n be two non-negative functions. Here f of n and g of n is non-negative functions and c be the constant value, and n0 represents the boundary value where it started. So and n is the maximum values taken. So n should be greater than equal to 0 and c should be greater than equal to 0. This is the constraint. So f of n is equal to, this is a formula for Bigo notation. F of n is less than equal to c into g of n. So c is nothing but constant. F of n and g of n is or both non-negative functions. So this can also be represented using the symbol O notation. That is, f of n is an element of order of g of n. So in the graph you can see at the position n0. So this is the variation. F of n is less than c into g of n. So it comes under down. So c into g of n should be greater than f of n. Next one is omega notation. Sorry, not theta notation. So omega notation is nothing but that is the vice versa of Bigo notation. That is lower bound algorithm running time. And it is represented as omega notation. Omega symbol is using, and we are going to measure shortest amount of time for running the algorithm. And the definitions are same. F of n, g of n is non-negative functions, and c is a constant value. So and c should be greater than equal to 0, and n should be greater than equal to 0. These are same definitions, and this is formula lightly different. That is in the old notation, Bigo notation less than equal to we are using, and here f of n is greater than equal to c into g of n. Yes, this can also be represented using the omega notation. That is, f of n is an element of omega g of n. So f of n should be greater than c into g of n. F of n should be upside and c into g of n should be lower side. Next one is theta notation. Theta notation nothing but it comes under upper and lower bound. It comes under intermediate position. It is represented using simple theta. So f of n and g of n two non-negative functions, and c1 and c2 are positive constant values. So this is a formula for theta notation. C1 into g of n should be less than or equal to f of n, less than or equal to c into g of n. So this can also be represented as f of n is equal to an element of theta g of n. So this is a graph. So at the position of n0, f of n is we can intermediate node, and c1 into g of n should be less, comes under f of n, and c2 into it takes the upper bound value. C2 into g of n takes the upper bound value, c1 into g of n gets the lower bound value. F of n should be in an intermediate position. So this is the asymptotic notations. And next we are going to see the properties. So these are the properties: reflexive property, symmetric property, transitive property, and transport symmetric. So these are the properties of notations. This is an important question because frequently asked questions in analysis. This is a very, very important question. So thank you.